Welcome students. Today we are going to start the 12th science first topic in section 2nd as per our new board syllabus. The name of the first topic is wave optics. नमस्कार विद्यार्थी मित्रांनो, 12वीच्या नवीन बोर्ड सिलेबसनुसार आज आपण सेक्शन सेकंडमधील फर्स्ट टॉपिक सुरू करणार आहोत की ज्याचं नाव आहे वेव ऑप्टिक्स. तो आजपासून आपण सुरू करूयात. There are a number of different points included in the new syllabus. We will discuss them one by one. Let us see the contents of these topics. In this lecture, we have to discuss introduction, nature of light, Newton's corpuscular theory of light, Huygens wave theory of light, dual nature of light, primary and secondary sources of light, wave front, wave normal, and Huygens principle. We know the laws of reflection and laws of refraction we have seen in 11th standard. Let us see the diagram for reflection. XY is the reflecting surface, NA is the normal, PA incident ray, AR is the reflected ray, I is the angle of incidence, R is the angle of reflection. The laws of reflection are: incident ray, reflected ray lies on opposite sides of the normal. The incident ray, reflected ray and normal lies in the same plane. The angle of incidence is equal to angle of reflection. These are the laws of reflection. The laws of refraction is same as that of the laws of refraction. The laws of refraction is same as that of the laws of reflection. Let us see the diagram for the refraction. Here XY is the refracting surface, NAM is the normal. The XY refracting surface separates the two media. Medium 1 is the rarer medium, have a refractive index N1. Medium 2 is the denser medium, have a refractive index N2. PA is the incident ray, AD is the refracted ray, AR is the reflected ray, I is the angle of incidence, R is the angle of refraction, R dash is the angle of reflection. The laws of refraction are: incident ray, refracted ray lies on opposite sides of the normal. Incident ray, refracted ray and normal lies in the same plane. And the third law called Snell's law, the ratio of sine of angle of incidence to the sine of angle of refraction is always constant. This constant is called the refractive index of the second medium with respect to first. We have learnt about reflection of light produced by the spherical mirrors. The position and nature of image, which is the real or virtual, depends on position of object and focal length of the mirror or lens. Here we have taken some ray diagrams for the concave mirror. Here in first diagram, the object is placed at infinity, then its image is observed at the focus of the concave mirror, which is real inverted. When the object is placed at the center of curvature of a concave mirror, then its image is observed at the same position, that is at the center of curvature, but it is inverted. The same size, real. In diagram 3, the object is placed beyond the center of curvature, then its image is observed between center of curvature and principal focus of the concave mirror. The image is smaller in size, called a diminished image of the object. This image is real and inverted. In last diagram, here object is placed in between center of curvature and focus of the concave mirror, then its image is observed beyond the center of curvature, which is maximum in size, inverted and real. Refraction through lens. We seen the types of lenses: convex lens, concave lens. Here the object is placed beyond the focus of the lens. First ray, shown by the red color, initially passes parallel to the axis, and after refraction it passes through the focus of the lens. Second ray, shown by the blue color, initially it passes through the focus, and after refraction it passes parallel to the axis. Third ray, shown by the green color, it passes through the optical center of the lens. These three rays cross each other, and at this point we get the image of the object. We have seen the different types of lenses. These are the convex lenses called converging lenses, and these are the concave lenses called the diverging lenses. Means rays are diverged from this type of lenses, and these are converging, means the rays, instant rays are converging using this type of lens, and we get the image of the object. Here the source is at infinity, is incident on the convex lens, then its image is observed at this point called the focus of the convex lens. This distance is called the focal length. Here source is at infinity, then its image is observed shown in figure. This distance is called as the focal length of the concave lens. We have learned about the refraction through the prism in 11th standard. We have done the experiment also, that is calculate the refractive index of prism. Prism's material is glass, and the refractive index of glass is 1.5. We have calculated in this. Also in theory we have observed the refraction through the prism. When white light is incident on the prism, then the spectrum of the different colors are observed through the prism. The different colors are ranges from red to violet. The different colors are shown in figure. When the white light is incident on the prism, then we get the different color, that is the spectrum of different colors, and the different colors shown separate here: violet, blue, green, yellow, orange and red. This is the angle of deviation, angle between the incident ray and the refracted ray. Angle of deviation is smaller for the red color, and it goes on increasing, and is maximum for the violet color. Here speed of red color is maximum, and it goes on decreasing up to violet color, means speed of violet color is small. The different theories of light which we have to discuss here. The Newton's corpuscular theory. Newton discussed the theory in 1675. For this theory he made some assumptions. The assumptions of the Newton's corpuscular theory are: according to Newton, the source of light continuously emits very small, weightless and elastic particles. Newton gave the name this type of particles as corpuscles. So the theory named as corpuscular theory, that is Newton's corpuscular theory. According to Newton, the different colors of light are due to the different masses and different sizes of the particles. When these particles enters our eyes, we get the sensation of light. The particles travels with high speed in a straight line through the same medium. This explains the rectilinear propagation of light. Light travels in a straight line, means rectilinear propagation. For reflection, he said that the particles are reflected by the reflecting surface, and for refraction, he said that the particles are attracted by the refracting surface. There are some drawbacks in Newton's corpuscular theory. drawbacks also it is called demerits. The mass of source remains constant. It does not go on decreasing because according to Newton, as the source of light continuously emits very small, weightless and elastic particles. Due to this, its mass must be go on decreasing, but this is not correct. The mass of source remains constant, not go on decreasing. This is drawback in Newton's corpuscular theory, because mass of sun, mass of any source of light, it remains same, not go on decreasing. This simultaneous reflection and refraction cannot be explained on the basis of the Newton's corpuscular theory of light. According to Newton, the velocity of light in a rarer medium is less than the velocity of light in denser medium. This theory is unable to explain some light phenomena like interference, diffraction, polarization, double refraction, etc. And due to these drawbacks, this theory was rejected. The another theory of light is Huygens wave theory. Huygens is the name of scientist and he studied the nature of light after Newton in 1678. According to Huygens, the light propagates through the medium in the form of waves. The different colors of light are due to the different wavelengths of light, and the wavelength of light increases from violet to red. The light waves enter our eyes, we get the sensation of light. According to Newton, the light particles, when the light particles enter our eyes, we get the sensation of light. But according to Huygens, when the light waves enters our eyes, we get the sensation of light. Here light travels in a straight line through the same medium. For the propagation of light through vacuum, Huygens assumed that there is an existence of an imaginary medium called a luminiferous ether medium, and it exists everywhere, that is in vacuum as well as all material bodies. Due to presence of ether, light waves propagates through the vacuum. In this theory, there are also some drawbacks. The presence of ether medium does not exist everywhere. Means this is drawback in Huygens wave theory of light. The rectilinear propagation of light cannot be explained on the basis of this theory. Some light phenomena like photoelectric effect, Compton effect, etc. cannot be explained on the basis of this theory, but there are some merits also. Here, the simultaneous reflection and refraction can be explained on the basis of the Huygens wave theory of light. Here, actual fact the velocity of light in rarer medium is greater than the velocity of light in denser medium, which is experimentally proved. The light phenomena like interference, diffraction, polarization, double refraction can be explained using this theory. The drawbacks in Newton's corpuscular theory was removed by the Huygens, so the Huygens wave theory was accepted. Light as a wave. There are two natures of light, that is particle and wave. Electromagnetic wave. Nature of light is electromagnetic wave. Let us see the diagram. Diagram is a three-dimensional figure. The direction of propagation of wave is shown along the x-axis. Y and Z are the three axes. Is electric field shown by the pink color, magnetic field shown by the blue color. These two fields, electric field and magnetic field, both are mutually perpendicular to each other, and these two are again perpendicular to the direction of propagation of light. Means according to Maxwell, light travels to the medium in the form of electromagnetic waves. Sun rays reaches us, which is in the form of electromagnetic waves. The electromagnetic waves are in transverse in nature. The nature of light wave is transverse. We have seen the transverse nature in 11th standard. This is the transverse wave. This nature of wave is transverse. We have seen the longitudinal wave also, but the nature of wave is different. This nature, sine wave, just like a sine wave. So the nature of light is transverse in nature. The electromagnetic waves does not require any material medium for their propagation. Means to propagate the electromagnetic in a medium, in a vacuum, there is not necessary for the medium. It travels through vacuum as well as all the material bodies. That is, electromagnetic waves does not require any material medium for their propagation. If n is the refractive index of the medium, then the refractive index is given by relation C by V, that is speed of light in a vacuum denoted by letter C divided by speed of light in medium denoted by letter V. In order to increasing wavelength of the waves are classified as, that is the electromagnetic waves is EM spectrum, electromagnetic spectrum. This spectrum consists of different rays: gamma rays, ultraviolet rays, visible rays, IR means infrared rays, microwaves, radio waves. These are the different rays called the electromagnetic spectrum. The wavelength of the visible light ranges from 400 nanometer to 800 nanometer. The visible light, the light which we can see, and its wavelength ranges from 400 nanometer to 800 nanometer. White light consists of a different color, that is, it is a mixture of a different color, and different color means different wavelength. Due to different wavelength, we see the different colors. Therefore, for same angle of incidence, the angle of refraction is different for different colors. Angle of incidence is same, but angle of refraction is different for the different color. Different color have a different angle of refraction. Dual nature of light means double nature of light, that is particle and wave. At the beginning of 20th century, it was accepted that light has a dual nature. It can exhibit particle nature and wave nature under the different situations. According to Planck's quantum theory, particles of light are called as the photons. Huygens theory, we have learned earlier the Huygens wave theory. We see the several sources of light around us like sun, stars, light bulbs, etc. The sources are divided into two types, that is primary source and secondary source. We want to see what is meant by primary source and what is meant by the secondary source. The sources of light that emit light of their own. The source of light that emit light of their own, called primary sources. For example, sun, stars, objects are heated to high temperature, that is flame of any kind, etc. TV, chemical and nuclear reactions. These are the examples of the primary sources. What is meant by primary source? The source of light that emits light of their own, called a primary source. And secondary source, the opposite to the primary source. Secondary source means the source of light which do not produce light of their own. The source of light which do not produce light of their own but receives light from some other source and either reflect or scatter it around. What is meant by secondary source? The source of light which do not produce light of their own but receive light from some other source and either reflect or scatter it around. For example, moon, planets, objects like humans, animals, plants, etc. are the different examples of the secondary sources. Then we have to see what is meant by wavefront and what is meant by wave normal. Wavefront, the locus of all the points of the medium to which all the light waves reaches simultaneously, so that all the points are in the same phase. This is the circle. Locus of all the points, group of different points called locus. Locus of all the points to which all the waves reaches simultaneously, so that all are in a same phase. These all waves are in same phase, and the circle is called as the wavefront. There are three types of wavefront. Spherical wavefront. The wavefront originates from the point source. If our source is a point source, then we get the spherical wavefront. Cylindrical wavefront. This wavefront originates from the source which is in the form of slit. If our source is in the form of slit, we get the cylindrical wavefront. Plane wavefront. What is meant by plane wavefront? Understand, the sun rays reaches us, which is in the form of plane wavefront. That is at a very large distance. At very large distance from the point source, very small part of the spherical wavefront gives the plane wavefront. What is meant by plane wavefront? At a very large distance from the point source. We are at a very large distance from the point source, and a very small part of the spherical wavefront gives the plane wavefront. The diagrams for wavefront and wave normal is shown in figure. Here the circles, different circles are the spherical wavefront. This is the original source, and due to this we get the wavefront, these types of the wavefronts. These are called the spherical wavefronts, and these lines, these are the radial, just like radius of the circle. These are called the wave normals. Wave normals means the perpendicular drawn to the wavefront, called wave normal. In case of plane wavefront, our source is at a very large distance from us, then we get the very small part of the spherical wavefront gives the plane wavefront. The standing line shows the plane wavefront, and the parallel lines, that is perpendicular to the standing lines, gives the wave normal. Means perpendicular drawn to the wavefront is called as the wave normal. In spherical wavefront, this is the spherical wavefront, and this is the wave normals. In plane wavefront, 1, 2, 3, these are the plane wavefronts and the parallel lines are called the wave normals, means perpendicular drawn to the wavefront called the wave normal. The definitions of the wavefront and wave normal. Perpendicular drawn to the surface of a wavefront at any point in the direction of propagation of light is called as a wave normal. Wave normal is the same as that of the ray of light. Wave normal for spherical wavefront is converging or diverging, and wave normal for plane wavefront are parallel. Huygens principle. What is the Huygens principle? The Huygens principle is, see the diagram here, the wavefront. We have taken the one wavefront at time t equal to 0. Time not equal to 0, but we have started to measure the distances. We have starting time we have taken 0. So at time t equal to 0, we have a spherical wavefront. The points A, B, C are on this wavefront. Here S is the original source. Huygens proposed that Huygens principle, every point on wavefront acts as a secondary source of light. Every point A, B, C are the points on the wavefront. Every point on wavefront acts as a secondary source, means point A1 acts as secondary source, B acts as a secondary source, C acts as a secondary source, because these points are on the primary wavefront. Every point on the wavefront acts as a secondary source of light. Secondary waves in all possible directions. The new secondary wavelets are more effective in the forward direction only. The resultant wavefront at any position is given by the tangent to all these secondary wavelets, means A, B, C are the secondary sources. It emits the light. So for this we have drawn the small wavelets. For B, this is the wavelet. For source C, this is the wavelet. And if we draw the tangential surface to all these wavelets, we get the secondary wavefront, means that after some time t, means time t equal to t, we get the secondary wavefront. This is the Huygens principle.